Hi, my name is Yusuf. Today I will be presenting Project 1 of Class Communication Theory with Peter Mathis. As shown in the picture, we have a binary communication signal using 7 bits ASCII. We have two types of signals. One is a triangle signal and the other one is an upside down parabola, or we can refer to it as a sine wave. But for the rest of this project, I'm gonna refer to it as a upside down parabola. We have 49 bits. Each 7 bits correspond to one ASCII character. We are going to decode this message to know what's the message that has been transmitted. And the way we are going to approach this is to see to match 1 and 0 to each of these two types of signals. At the beginning, I set the triangle signal to be 1 and the upside down parabola signal to be 0. I got a very weird signal, very weird message that has no meaning. So I had to switch. I chose the triangle signal to be 0 and the upside down parabola signal to be 1. The message that has been transmitted was gravity with the capital letter G, and the rest of the letters were lowercase. The ambiguity, the ambiguity in this signal was just because we had to match the 1 and 0 logics to the types of signal that is supposed to correspond to in order for the message to be meaningful. The second part of this project is to see whether this signal is suitable for the real-life communication. I would say not really, since the similarity between the triangle signal and the upside down parabola signal is very high. We cannot really distinguish whether which one is 1 and which one is 0, especially if there was a noise in the system. To prove that the two signals has a very high similarity rate, I had to find the correlation between the two signals. The correlation function is given by 1 over the square root of Ex, which is the energy of signal X times the energy of signal G. In my case, energy of signal X is the is upside down parabola, and the G is the triangle function, times the integral from 0 to 1 x of t times g of t, all multiplied by dt. So first of all, I set the function of x of t. So I found the function for the parabola signal, which came out to be negative 4 times t minus half to the squared plus 1. And then I took the integral from 0 to 1 of x of t squared, and that came up to be 8 over 15, which is the energy of x. Then I had to find the function for the triangle. So I had to set two integrals. One that correspond to the left side of the triangle, which is 2t, and the second one that correspond to the right side of the triangle, which is 2 negative 2t. So the energy of the triangle function will be from 0 to half 2t squared dt plus from half to 1 2 minus 2t squared dt, which came out to be 1 over 3. So the correlation after doing the computation came out to be 0.98819. So in this case, we see that the correlation coefficient is very high, which is close to 1. So as the correlation coefficient is close to 1, there will be higher similarity that the signal will be less resistant to noise. As it gets to close to negative 1, it will be less similarity and more resistant to noise. So to see whether the signal would work if it were transmitted over a channel that does not pass DC, I had to calculate the average DC value for each of the signal. So for the triangle signal, it came out to be 0.5, and for the parabola, it came out to be 0.6. So as someone can see that there is no big difference between the DC average the DC average value with the triangle and the parabola function. So someone can conclude that the signal would not work if it was transmitted over a channel that does not pass DC, since they are very similar to each other even in the DC value. An alternative waveform that I would use to transmit the message I found in part 1 would be a unipolar encoding waveform, since it has zeros and ones, where zeros correspond to no voltage and ones correspond to positive voltage. Its implementation acts like a switch off when there is zero voltage, which corresponds to a zero in binary, and on when there is a positive voltage, which corresponds to 1 in binary. It has higher resistivity against noise than the one in the question, since it's more distinguishable.